Welcome to your Algebra 2 3.2 lesson. This is video number 1, and we're going to solve linear systems algebraically. We did them graphically last time. Today we're going to do them algebraically. So your objective is going to be to solve linear systems using algebraic methods, and basically we're going to learn two: substitution and elimination. For substitution, the first thing you're going to do is solve one of the equations for its variables. Then step 2, you're going to substitute the expression from step 1 into the other equation and solve for the other variable. In step 3, you're going to substitute the value from step 2 into the revised equation from step 1 and solve. So just like it says on your note sheet there. Alright, so for example 1, we're going to solve the system using the substitution method. Now I do want to point out you need to be able to do both methods, because on the test there will be some problems where I tell you to use the substitution method, some problems where I tell you to use the elimination method, and some where you get to choose. So you need to make sure you can do both methods. Alright, so for this example, equation 1, and you need to label it, is 2x plus 5y equals negative 5. Equation 2 is x plus 3y equals 3. Okay, now substitution method is going to be best used when you have one of the variables that either has 1 or negative 1 as the coefficient. So if you look in equation 2, that's what we have. We have a plain x that has an understood coefficient of 1. So we're going to solve for x in equation 2. So our first step is going to be to solve equation 2 for x. So that means we need to subtract 3y from both sides, and we get x equals negative 3y plus 3, or if you had x equals 3 minus 3y, that's fine too. Now, the next step is actually the substitution step, the main substitution step. We're going to substitute negative 3y plus 3 for x in the other equation, so in equation 1. Okay, so we're going to substitute the expression for x into equation 1 and solve for y. So write equation 1 down, 2x plus 5y equals negative 5. So now we're going to replace x with what x equals, negative 3y plus 3. So see the red x there? Now in red, because it's replacing x, we've got negative 3y plus 3. So we've got 2 times negative 3y plus 3 plus 5y equals negative 5. Now, your next step, you need to distribute that 2, because we're going to solve for y. So you're going to get negative 6y plus 6 plus 5y equals negative 5. Negative 6y plus 5y equals negative y. So you'll get negative y plus 6 equals negative 5. Subtract 6 from both sides to get negative y equals negative 11. Divide both sides by negative 1, and you get y equals 11. Okay. Now, so we have y, but our answer is going to be an ordered pair, x, y, so we need to know x. So now we're going to substitute 11 for y into revised equation 2 and solve for x. You could actually do it in either of the original equations too. It's just you have an x equals equation for that revised equation 2, so that might take you a little bit less time. So we've got x equals negative 3 times y plus 3. So we're going to substitute 11 for y. So we have x equals negative 3 times 11. Notice in blue there, so that to help remind you that we're substituting 11 for y, because we know y equals 11 for this system, plus 3. So that's negative 33 plus 3, so negative 30. So x equals negative 30, y equals 11 is your solution. Now we want to check this. We check it exactly like we did with the graphing problems, because this means the same thing. If we were to graph those two lines, this is the point where they would intersect. So we're going to plug in x equals negative 30, y equals 11 in both equations and make sure they balance out. Okay, so we're going to check this solution by substituting into the original equations. All right, so we've got it was 2x plus 5y equals negative 5. So now we've got 2 times negative 30 plus 5 times 11 equals negative 5. 2 times negative 30 is negative 60 plus 55 equals negative 5. For the second equation, we had x plus 3y equals 3. So we're going to substitute in negative 30 for x, 11 for y. We get negative 30 plus 3 times 11 equals 3. Negative 30 plus 3 times 11, 3 times 11 is 33. Negative 30 plus 33 is 3. So yay, our solution checks there as well. So we know for sure that negative 30, 11 is the solution. Okay, for example 2, we're going to solve the system using the elimination method. Really quickly, I just want to point out to you, look on your note sheet. Okay, we've got 3 steps for the elimination method. Number 1 is multiply one or both of the variables by a constant to obtain coefficients that differ only in sign of one of the variables. So you want like 2x, negative 2x, or y, negative y, or 7x, negative 7x. You want one of the variables to be opposites of each other in the equations. So you want them to differ only by the sign. Step 2, add the revised equations from step 1. When you combine like terms, you will eliminate one of the variables, solve for the remaining variable. Okay, so then once you have that value for step 3, you're going to substitute the value obtained in step 2 into either of the original equations and solve for the other variables. Now, I've got to warn you, the publishers have a typo in this lesson, in this example. We'll see if you can find it before I tell you about it. Okay. Equation 1 is 3x minus 7y equals 10. Equation 2 is 6x minus 8y equals 8. Okay, so looking at this, I want opposites. The easiest way to get opposites in front of one of the variables, because you're comparing 3 and 6, and then negative 7, negative 8. Well, with the 3 and the 6, if I just multiply the top equation by 2, I would get the same value. I would get 6. But if I multiply by negative 2, I'm going to get opposites. So I'm going to multiply everything in equation 1 by negative 2, all the way across. So the 3x will get multiplied by negative 2, the negative 7y will get multiplied by negative 2, and so will the 10. So we're going to multiply equation 1 by negative 2 so that the coefficients of x differ only in sign. So I'm going to take 3x minus 7y equals 10. And I'm going to get negative 6x plus 14y equals negative 20. They got carried away with pressing the 2 key. That first 2 there should be a negative. So don't write down 220 on your paper. Write negative 20 on your paper. These aren't editable, so I can't go change that. But it equals negative 20. Okay? The other equation we don't need to change, but go ahead and rewrite it so that they're stacked. And so you have 6x minus 8y equals 8. So we have negative 6x plus 14y equals negative 20, not 220. That's a typo, and I can't fix it, which drives me nuts. It's negative 20. And then 6x minus 8y equals 8. Now we're going to add them up. Well, the negative 6x plus 6x are going to zero out. 14y minus 8y is 6y. And then negative 20, not 220, negative 20 plus 8 is negative 12. We're going to divide both sides by 6, and we get y equals negative 2. Okay, now we can go back to either one of the original equations and plug in negative 2 for y, and then we'll solve for x. I think it's going to be easiest to do it. I mean, it really doesn't matter if you do it in equation 1 or 2. Since it doesn't matter, I don't want to spend a lot of time thinking about it, so I'll just go with equation 1. So we're going to have 3x minus 7y equals 10. Plug in negative 2 for y. Excuse me. And you're going to get 3x minus 7 times negative 2 equals 10. So 3x plus 14 equals 10. And let's see, subtract 14 from both sides. You'll get 3x equals negative 4. Subtract the 14, you get negative 4. 3x equals negative 4. And so divide by 3, you get x equals negative 4/3. And so your solution is negative 4/3, negative 2. Okay, great. All right. Well, we're going to end video 1 here, and then I will meet you back here in just a second for video 2.